Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.53. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always zero. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.53. Find current IL in given below figure. This is the circuit diagram of given problem. We have to find the value of current IL through this 3 kilo ohm branch. So without wasting time, let's proceed towards the solution. This network contains 3 current sources. We will try to merge these together to form a single current source by subtracting 3 mA and 3 Ix from 6 mA because of opposite direction. Final current source will have the direction of upward entering to this node, and the value of final current source will be 3 mA minus 3 Ix. This is the reduced form of circuit by merging all current sources together. Now we will apply Kirchoff's current law to solve this problem. In this circuit there are two number of nodes. One is reference or ground node, and other node it will be used for the application of Kirchoff's current law. All currents entering or leaving on this node will be taken with the reference of this ground node. In this circuit, the polarity of all entering currents or leaving currents on this node are mentioned except this 2 kilo ohm resistance. So we have to assume the direction of current inside this 2 kilo ohm resistance. If we observe, voltage across this 6 kilo ohm resistance along with their polarity is provided here. This same voltage with same polarity will also be appearing across all other elements because of parallel connection. So we can say that voltage across this 2 kilo ohm resistance will have positive terminal here and negative terminal here. And we know that according to passive sign convention theory, positive terminal of a resistive element is current entering terminal and negative terminal is current leaving terminal. So according to this theory, the current direction will be downward. Now inside this network, we know the polarity of all entering and leaving currents. We can apply Kirchoff's current law on this node. KVL equation for this particular node will be, first of all, entering currents will be taken. Only one current is entering, 3 mA minus 3 Ix, while rest of all other currents are leaving from this node, and those are Ix, IL, and current of this 2 kilo ohm resistance, that is calculated using Ohm's law. Voltage across this element V1 divided by the value of resistance 2 kilo ohm. So the equation is 3 mA minus 3 Ix minus V1 divided by 2K minus IL equal to 0. Now place the values of IL and Ix in this equation. Value of IL will be voltage across this 3 kilo ohm resistance, that is V1 divided by the value of resistance 3 kilo ohm. So the value of IL will be V1 divided by 3K. Similar case will be with this Ix. Value of Ix can be calculated voltage across this 6 kilo ohm resistance, that is V1 divided by the value of resistance 6 kilo ohm. Here we have replaced all variables with their values. Now inside this equation only one variable is left, that is V1, so we can calculate the value of V1. If we succeed to calculate the value of voltage V1, then in that case we will be able to calculate the value of IL, that is equal to V1 divided by 3K. So first of all, we will try to solve this equation to calculate the value of voltage V1. For that purpose, we will multiply this equation with 6K on both sides to omit these denominator values. These both 6Ks will cancel out with each other. Similar case will be here. These both 6Ks will be cancel out with each other. and this 6k will divide with 2k, the answer will be 3. And this 6k will divide with 3k, the answer will be 2. Product of 3 milli and 6k will become only 18, milli will cancel out with k. And product of 3 and v1 will become 3v1. Here only v1 will left, so v1 is taken here. Here 3 will multiply with v1, it will become 3v1. And at the last 2 will multiply with v1, it will become 2v1. Now add all these values that include variable v1 together and place that on the other hand side of equal. The equation will become 18 equal to 9v1. Divide on both sides with 9 to calculate the value of v1, that will become 2 volt. So we have calculated the value of voltage v1. Now we can easily calculate the value of current IL, that is equal to v1 divided by 3 kilo ohm. Value of v1 is 2 volt, so IL will become 2 divided by 3 kilo ohm. Finally, the value of IL inside this network will become 0.67 milliampere. So this was exercise problem number 2.53. Thank you. See you again in next video.